Hello and welcome to 2.4. This is all about slope again, so nothing too major, but we will be talking about parallel, perpendicular, vertical, horizontal, how those were in effect, and then how to write equations knowing that something's parallel and perpendicular. So get your notes out and let's get going. All right, when you look here, we have equations of a line, parallel and perpendicular. We will be talking about rate of change, because that's what slope is. It's a rate of change, how something changes versus something else. And average rate of change. So we're going to change a curve into a line, basically is what that is. So all of this is just ways to say parallel. Okay, if two non-vertical lines are parallel, they have the same slope. If two non-vertical lines have the same slope, then they are parallel. So you can do it either way, correct? It's an if and only if, basically. If two distinct vertical lines with undefined slopes are parallel. So if they're both undefined, or actually if they're both zero, they could be parallel. So write an equation of the line passing through -2, 5 and parallel to y equals 3x. This is a little tricky because I only need a slope and a point to write an equation. So the only thing I need here is the 3. This is there to mess you up. So you know the slope of your line is 3. We know a parallel lines, this is a symbol for parallel, the slope is the same. So the slope is also 3. So we're going to use 3 with our point to write the equation. So it's y minus 5 equals 3 times x minus technically a -2, which means plus 2. And we're done. I didn't ask you for a certain form, so that's finished. All right, try yours. A little bit trickier because they gave you 2 unneeded information. You don't care about, because this is point slope form, so we don't care about the point. We only care about the slope. So we know my given slope is 7. Parallel slope then is also 7. So we use 7 with the point to write the equation. So y minus a -1 or plus 1 equals your slope times x whoops, that's an x, minus 6. And you're finished. All right, next we're going to talk about perpendicular. And this is just ways to say perpendicular again. If two lines are perpendicular, the product of their slopes is -1. If the product of the slopes is -1, then the lines are perpendicular. And horizontal and vertical lines are perpendicular. Here we go. So we're looking this here. We're given our slope is equal to 4/3. Well, the perpendicular, this is a symbol for perpendicular, this has to equal -1 when you multiply it. So we know we multiply by the reciprocal to get 1, which is 3/4, but negative means it has to be negative. So it's the opposite. Reciprocal is how you would have learned this like the last 3 years, I think. So now I have my slope and my point. I'm going to write the equation in my line. Y minus 3 equals a -3/4, opposite reciprocal, times x minus 2. Nothing too earth-shattering yet, right? Okay, let's do our story problem. Okay, we have here a slope is defined as a ratio of change in y to a corresponding change in x. So change in y over change in x. How fast y is changing with respect to x is what it means. Now we want to interpret this in this here story problem. So the first thing we do is we figure out what we know. So in 1990, 9 million men and adults were lonely. So we got 9 million in 1990. I bet this is a point because this is a year. I have 9 million lonely males, basically. In 2008, we have 14.7 million lonely males. We will use this information to find the slope of the linear function. All right, so let's find the slope. So I'm going to do change in y. Let's do 14.7 minus 9 over 2008 minus 1990. Okay, get out your calculators. Make sure you get this right. So I've got 5.7, if I did my work right, over 18, and that's equal to 0.32. What does this mean? All right, so now we have to figure that out. This means, since this is positive, every year in the US, United States, the number of lonely men is increasing by 0.32 million. So it keeps going up. Means that's good for us girls, but not so good for the guys. All right. Average rate of change. This one here is a little bit weird. For x cubed. I know x cubed is, remember, the S shape. So there's nothing straight in this thing. I want to know if the average rate of change is like from -2 to 0. In other words, I'm going to draw a line from here to here and figure out what its slope is, because that's what's considered the average rate of change. So what we do is we say, what is this number? What's the y value? Which is, what is the f of -2? So what's the y value at -2 minus the y value is what f of 0 means, all over -2 minus 0. So this is change in y over change in x. So we just plug the -2 into x cubed. Well, -2 cubed is what we have here, is -8 minus, well, that's just 0, right? Anytime you plug in 0 to x cubed is 0, all over -2. So -8 divided by -2 is 4. So our average rate of change is 4. Okay, pause and try yours. Okay, from 1 to 4. So that means I have to find the y value, because that's what f is, of the 4 minus the y value of 1 all over the x value, which was the 4 minus 1 that we plugged in. So we're going to plug the 4 into this equation. So over here, I'm going to say, hey, 4 squared plus 3. So that's 16 plus 3, which is 19. So that's 19 minus. Now let's plug in 1. 1 squared plus 3. Well, that's 4. All over 4 minus 1. Well, I know that's 3 already. So I've got 15 over 3, which is 5. So my average rate of change is 5. All right, pause. Good luck on your homework. Make sure you're asking questions. And don't forget to do this. This is very important. Look at those graphs on page 283 for tomorrow. Make sure you know which one is which. And you notice a few things about them. I don't care what you notice, but see how they're similar and how they're different. Okay, good luck.